Hello everyone, welcome to ACE Anesthesia. So today's topic of discussion is scavenging systems. This was a topic that was requested by one of our subscribers. So in this video, we'll be seeing about what is scavenging systems, then what is the importance of having a scavenging system, techniques that will help us to reduce operation theatre pollution, and we'll see about the components of the scavenging systems, right? So coming to what is scavenging systems. Scavenging system is basically it collects and disposes the vented anesthetic gases out of the operation theatre, right? That is called as the scavenging systems. So scavenging systems is very important for all of us to reduce the operation theatre pollution. Now coming to what is the importance of scavenging systems, because we use inhalational agents as well as other agents like nitrous. So these agents cause operation theatre pollution. It has been found that chronic exposure of these agents has caused reproductive issues in the female anesthesiologist. Especially like nitrous, these are associated with interference in the enzyme that is methionine synthase, which is very important for the B12 production. So coming to what are the techniques that will help us to reduce this operation theatre pollution. So operation theatre pollution, it can be reduced with certain techniques, right? Which includes like having a good mask fit around the patient's face, right? Second is using a cuffed endotracheal tube rather than an uncuffed tube. Third is discontinuing the agents when the circuit is disconnected from the patient. Okay. Fourth is avoid any spillage of liquid agents during the time of filling, right? Fifth is having a good scavenging system in the operation theatre is also important. Sixth is using total intravenous anesthesia. So these are the various techniques or methods by which we anesthesiologists can reduce the operation theatre pollution, right? So next, one of the important guidelines, that is National Institute of Occupational Safety and Health, that is called as NIOSH, that is National Institute of Occupational Safety and Health. They have given the time weighted average in parts per million of the anesthetic gases, that is halogenated agents and nitrous, which is allowed for exposure. Okay, if you are using only halogenated agents, the value in time weighted average will be 2 parts per million. Okay, if you are using nitrous, it is 25. If you are using like a combination of halogenated agents and nitrous, it is 0.5 for the halogenated agents, okay, and 25 for the nitrous. So this table, in fact this lecture is concised from Miller's itself. So this table you can add up to the content when we get this question in exam. So next we'll be seeing about the components of the scavenging systems. So here I have briefly told about I have written in this board about the various tubings through which the gases will encounter before it goes up for the disposal. So first we have a gas collection assembly that basically collects the scavenging gases from the ventilator. Okay, then it will be going to the transfer tubings, then it will go to the scavenging interface. After that, it goes to the gas disposal tubing, and then lastly comes the disposal of the gases, right? So starting with the gas collection assembly. So gas collection assembly basically collects the gases from the ventilator. So these are the vented out anesthetic gases. Okay, from the ventilator it will be collecting. So here it will be in the form of an APL valve or exhaust valve. Okay, they will be collecting these vented out anesthetic gases for disposal. So in case of a bellow type of ventilator, right, there is a presence of the pop-off valve, okay, that will be collecting these vented gases. Whereas in case of a normal, that is in case of bellow type, we have a pop-off valve. Whereas in case of a pneumatic type of a ventilator, we are having like a APL valve with minor holes that will be venting out these gases. So this is the gas collection assembly. Next we come to the transfer tubings. So transfer tubings are basically the rigid hoses which will be transferring these vented out gases from the gas collection assembly to the scavenging interface. So these transfer tubings are basically color coded, right? They will be basically yellow in color. They will be rigid tubes in order to sustain the pressure, and in contrast to our normal tubings which are 20 mm connectors, our scavenging system is a 33 mm connector. So these are the differentiating features which will help us to differentiate these scavenging tubes from our rest of the anesthetic gases tubes. Next we come to the scavenging interface. So scavenging interface is basically the one that will be helping in managing the pressure within the system between minus 0.5 centimeter of water to plus 0.5 plus 5 centimeter of water. So minus 0.5 centimeter of water to plus 5 centimeter of water will be the range of pressures which will be dealing with the scavenging systems. Some of them will also contain like a reservoir bag in order to ensure that even if there is very less anesthetic based gases being produced, the negative pressure is not produced within the scavenging system that may cause the gas to get withdrawn from the patient circuit. So reservoir bag that is present often within the scavenging system is meant for this purpose. Okay. So when we come to this scavenging interface as I said, they can be an open interface, okay, or they can be a closed interface, right? So before discussing about this, let me tell you about the scavenging systems which can be basically classified into active systems and passive systems. Okay. So in active system, the waste gases are getting disposed into this vacuum through a suction. That is, it is getting actively sucked in and it is getting disposed through these vacuum tubes through a suction. That is called as this active systems. Okay. So in these are called as active systems. Whereas in passive systems, it is basically the pressure of the circuit, because whenever we are delivering the pressure of the circuit, which will be a positive pressure, that in turn will be driving the disposal of the gases through the heat, air conditioning and the vacuum systems which are present in the operation theatre, which is called as the HVAC systems. Okay, this comes as the passive systems. So when we are coming back to this scavenging interface, so when the scavenging interface comes into picture, these are of two types. we have open interface and a closed interface, right? So open interface means there is communication of these systems with the atmosphere is called as an open interface. So an open interface type of the scavenging interface, it is seen in case of the Draeger machines, whereas a closed interface is where there is no communication with this atmosphere. It is seen in case of Datex Ohmeda, right? So coming first to the open interface system. So this is the brief diagrammatic representation of how an open system looks like. So as the arrow shows, this is for the entry of these waste gases. Okay. Then we have a suction regulating port. Okay. Here it goes to the central vacuum. Okay. Here is the flow meter, right? And this is the waste gas tube. Okay. And this one, this is the vacuum tube. Okay. There's a special valve, that is a special relief port which is present. Okay, that is called as a relief port, that is seen. So when we come to see this, the gases will be flowing from the top to the bottom of this canister, right? And they are actively driven by the suction regulating port to the central vacuum. Whenever the system recognizes that the pressure within this vacuum, that is the waste gas production, is much less than that of the pressure within the system or this atmospheric pressure, the relief port ensures that some amount of air is entrained so that so much of negative pressure doesn't build up within this central vacuum system. So this is the mechanism of an open scavenging interface. Now let's see about the closed scavenging interface. So closed scavenging interface, it is seen in case of Datex Ohmeda machines. So in a closed scavenging interface, these again are classified into two types, that is active type and a passive type. So as I said before, the systems can be classified into active and passive systems, right, based upon what is driving the suction. So this is a brief diagram of what a active system looks like. So what is basically a closed interface with a passive system means they have only a positive pressure relief valve. Okay. The pressure will be relieved only for excess positive pressure at plus 5 centimeter of water, right? So these basically, as I said in the passive systems, because of the positive pressure within the circuit, they will be going into the HVAC systems of the operation theatre, right? So next, coming to this closed active interface, this is the diagram of a closed active interface of the scavenging systems. So here in active interface, they will be having both positive and negative pressure relief valve. Okay. So here the components of this includes, they have a positive pressure relief valve at plus 5 centimeter of water. They have a negative pressure relief valve at minus 1.8 centimeter of water. And they have another auxiliary negative pressure relief valve at 0.5 centimeter of water. Okay. Here will be this entry of the waste gases. There is a vacuum adjusting valve. Okay. And there is this goes to this central vacuum. Okay. And there are the various shapes which is present of the reservoir bag. So this that is present is the ideal shape which the reservoir bag is present. This is the collapsed bag and this is the overinflated bag. So in a closed active system, it has both positive as well as a negative pressure relief valve. Ultimately, this ensures that the pressure is maintained within the system for the disposal of the waste gases. So because it is an active system, it has kind of a vacuum suction that will vent out it to the central vacuum that is present, right? So this is a brief diagram which everyone has to remember of the closed active systems, right? So after finishing this scavenging interface, we have the gas disposal tubings which will be help in delivering these scavenged gases to the gas disposal system, that is to the atmosphere or the operation theatre disposal system. These tubings which are present, they are coded by diameter index safety systems for the purpose of maintaining the safety. So we have come to the end of this video. We saw what is a scavenging system, what are the hazards related to the operation theatre pollution, what are the techniques which we can use to reduce this operation theatre pollution, and we saw a little bit about the components of the scavenging systems in detail. So this was a brief video about this important topic. I hope this was useful. Keep supporting. Thank you.